Alright, we're looking at the practice test for trigonometry. Before we start, just make sure you've got your formula sheet and your calculator. So, first question, we want to label this triangle. So the hypotenuse is across from the right angle and it's the longer side. The opposite is the angle, the side across from the angle here. And then the adjacent is the side which touches the angle there. So we'll find the opposite first. We can go that tan of 30 is opposite over adjacent. So that's opposite over 5, because the adjacent is 5. So there we go. So we can rearrange this. We can get the opposite is 5 times tan of 30. And we can just chuck that into a calculator. So make sure your calculator's in degrees, because the angles are measured in degrees. You're going to go Shift, Setup, go down to degrees there. And we want to go 5 times tan of 30, and we're going to get S to D at 2.89. So that's opposite is roughly equal to that. Okay, so now that we know that this length is 2.89 meters, we can actually use that to get the hypotenuse a bit easier. So the hypotenuse squared is the adjacent squared plus the opposite squared. And that is just from Pythagoras. Okay, so that is 5 squared and 2.89 squared. And so we get the hypotenuse squared roughly equals. So we can take that 2.886 full version and square that. And then I'm going to add on 5. So use the full version of numbers when you're dealing with them. So we're going to get 33.3, and therefore the hypotenuse is the square root of 33.3, which is roughly equal to whatever the calculator tells us. Square root of that answer, we've got to use the full version. So it's 5.77. And we'll just pop meters there. That is the hypotenuse. So there we go, 2.89 meters and 5.77 meters. Okay, next question, convert 30 degrees to radians. So if you have a look on the formula sheet, by the way, there was that SOHCAHTOA stuff we just used. Radian degree conversions here. So to convert to radians, you've got to go and times by pi over 180. Now, this is absolutely something you can do by hand, or if you want, you can do it on the calculator. It doesn't really matter too much. So it's 1/6 of pi, or in other words, that's pi over 6. The way you would do it by hand is you go 30 pi over 180, and you can imagine simplifying that fraction down. So divide the top and the bottom by, I think it's 30, and you'll get pi over 6. Convert pi over 4 radians to degrees, so you go to times by 180 over pi here. The pi's will cancel off essentially, and you'll be left with 180 over 4, which is, and we can see what that is. So it's 45 degrees. Since it's degrees, we've got to put a little circle-y degrees sign up there. Next, we've got a triangle here. So let's start by labeling it. So let's label this angle here as big C, and then that side's going to be a little c across from there. We can label this one as A and B, and then if we want, big A is across there and big B is across there. So we got an area formula, and it is sitting just down here with the sine rule. So half AB sine C, just like that. There we go, half AB sine of C. And that's going to be half, and it's 5, 6 sine of 55. Make sure we're in degrees, which we still are. It says it up the top there. So we got a half, 5, 6, and sine of 55. So it's 12.3. Notice I'm going to 3 significant figures with all my answers there. So area is 12.3 meters, and it's meters squared because it's an area. Calculate the missing side length. So we've got 2 sides in an angle. That means that we've got to use the cosine rule to find that. Cosine rule just lives sort of here on the formula sheet. So the side that we're trying to find is C, so we'll use this bottom bit of the cosine rule. Let's see how that works. C squared is a squared plus b squared. Starts up a bit like Pythagoras. Take 2ab cos of c. So that's 5 squared, 6 squared, 2, 5, and 6, and cos of 55. That's c squared. We can chuck all that in a calculator. So 5 squared, 6 squared, 2, 5, 6, and cos of 55. Make sure you're in degrees still, not that you would have changed it. C squared is about 26.6. So C would have to be the square root of 26.6. And we can work out what that is. So there we go, 5.16. Now it's not a bad idea to just pop something like cosine rule there, just to show the marker what you're doing. That's mainly important in show that questions, but if you have extra time, it's good just communication skills to put that when you can. Okay, that's good. Find the other two angles of the triangle. So one angle we can find using the sine rule. So if we want to find that angle B, for example, we can use, in the sine rule, finding an angle, we use the top version. So the top version looks like this. Sine A over A is sine B over B is sine C over C. And you want to pick basically only 2 out of 3 of these things. And we know what the angle C is, and we know what the side length C is. So that is good news. So basically I'm just going to get rid of that sine A bit there. So I'm left with sine of B over B equals sine of C over C. And then we should know 3 out of 4 of those things. So I don't know big B. So I'm just going to leave that sine of B over. I do know what little b is. It's 6. I do know what big C is. It's 55. And I do know what little c is. We just worked it out. So 5.16. Okay. Well, that's good. So now we can just swap it around. So sine of B is sine of 55 over, well, this should be approximately equal sine because it's about 5.16, not exactly. So over 5.16 times 6. Okay, so that is that sine of B approximately equals. So it's sine 55 on the top. It is that answer. So I'm just going to go shift answer on the bottom and then times 6. So we get this 0.953. So B would have to be inverse sine of that, which roughly equals, so inverse sine of the answer, 72.4. Cool. All right. Now with this triangle, I've got that bottom angle is 72.4. That angle is 55. So that means that our last angle A, well, all 3 angles, would have to equal 180 degrees. So we can just go like sum of angles in a triangle, something like that. So that's A plus 72.4 plus 55 equals 180, or approximate because that was about 72.4. So A would have to be 180 take 72.4 take 55. And if I go 180 take shift answer take 55, that should give me 52.6. A is about 52.6 degrees. So that's a way you can get the last angle really quickly, or you could just use the sine rule again. Or if you really want with these cosine rule ones, you can do the finding angle version if you have 3 sides. All right, next up we've got a graphing question, and this one's about ogres living in a certain swamp. You'll never guess what my inspiration was. First thing we need to do is just go into setup and swap our calculator to radians. So it would be on degrees, swap it out to radians. Whenever you do a trig graph, it's in radians. So then you're going to go to menu graph, and we're going to graph this. So 19 sine, open a bracket, put a fraction, pi on the top, and 6 on the bottom. And then we're going to have t take 4. So that's x take 4, plus 45. All right, now I've given you the window in the question here. So it looks like x goes from 0 to 14. So 0 up there, 14 up there. And y is going to go from 0 to 80. So 0 to 80 there. If we exit out of that and draw, we get a lovely graph of ogres. So let's get some key features on our graph. So if we go into trace and go 0, you can see the ogres started about 28. So we're going to try and put that on our graph there. 28.5-ish. There it is. Just try and be fairly accurate as you're graphing this. Some other key features we might want are our minimums and maximums. So if we just go and draw it, G-solve and then go min, 1 with 26. So where it's got 1 there, I should be up at 26. So it's about there. And the next minimum, it's a little bit out of the range, but it would be at 13 and 26. So roughly there is what we're aiming for. And if we go into G-solve max, we can get our maximum value in the middle. So that's 7 with 64 ogres. So that would be right up there. And that gives us a pretty nice shape. If we want, we can go trace and get some in-between values. So maybe at like 4, it's at 45. So that's good to know. So we put a dot there. And then if we go trace at, I don't know, like 10, it's also at 45. So if you get a few dots on there, that should give you enough of a general shape to draw your sine graph. Try and make sure it's not too spiky. Make sure it's like a nice and smooth sine graph. There we go. Okay, so then we got to put the equation on. So arrows on the end of the graph, and then equation. P of t equals 19 sine pi over 6 t take 4 plus 45 ogres. All right. When is the ogre population at its lowest, and how many ogres are in the swamp at this time? So if we go G-solve min, you get 126. So at t equals 1. Now 0 was January 1st, 2001. So, and the time is in months. So this is at Feb 1st, 2001. So at t equals 1, there are 26 ogres in the swamp. And this is the min value. Cool. Calculate P 2.5. So that's going to be trace and type 2.5. So you get 31.6. So we can say at t equals 2.5. So this would be about March, and let's go 15th. You can, if you want, do that like formally. So one way to do it is, well, 2 is March because we're sort of off by a month. January is 0, February is 1, March is 2. And then you can go 0.5 times 31, there's 31 days in March. So technically that's March 16th. At t equals 2.5, so that's March 16th. There are 31.6, so about 32 ogres in the swamp. Cool. All right, townspeople will invade the swamp if there are 50 or more ogres in there for any longer than 3 months. So the way that we do this is we go G-solve across xcal, and we type y is 50. So if p is 50, t would have to be 4.51 to, and these are approximates. And if you hit the right arrow, you'll get the next one, 9.49. So the total time approximately equals, and now let's go into run matrix. So you got 9.49 take 4.51, so 4.98 months. So yes, that's longer than 3 months. So yes, they will invade the swamp. Poor Shrek. All right. Wonderful. All right. Pizza has been cut into 8 slices, so we got to explain why the angle is pi over 4. So total around pizza is 2 pi, so that's like the 360 degrees, into 8 pieces is 2 pi over 8, which is pi over 4, and this is like simplifying. And I guess this is 8 equal pieces. Calculate the area of a single slice. So this is where we've got these area formulas here. So just these ones here, we're in radians, which is good. Half theta r squared. So area is going to be half theta r squared. So that's half 1 over 2 times, and then we got pi over 4 times, and then r squared. So that's 15.24 squared, just like that. Okay, so we can work that out. 0.5 is half times, and then we've got shift pi over 4 times 15.24 squared. Okay, 91.2, that's roughly the area, 91.2 centimeters squared. Calculate the length of crust, so length is theta r, so that was those same formulas there, theta r. So that's going to be pi over 4 times 15.24. So we can work that out. Pi on the top or on the bottom times 15.24. So that is about 11.9 or about 12.0 centimeters. Should pineapple be put on the pizza? Yes, it absolutely should. All right, pictured alongside is a landmark. So the total height is given by that graph there. We're going to model it using a trig function. So usually the easiest way is to start with the d value. So if you want, you can have a formula for this. It's the average of the max and the min heights. So if you want, it looks like the minimum height is 1.5 and the maximum height seems to go up to 2.5, about that. So you can go 1.5 plus 2.5 all over 2. So that is 4 over 2, which is 2. Now that's the way you can do it with the formula if you want, or you can sort of just look at the graph. The center point, that's y equals 2. It goes through the center of the graph exactly, and that's your d value. Next easiest one to find is the a value. So the a value is the distance from the center point up to the line, which looks to be 0.5. If you want a formula for it, it's max minus min all over 2, if you want a formula for it. Now b is 2 pi over the period of the graph, and since this is a graph of tides, the period will be 24 hours because it cycles through every day. And you can sort of see that it's about to loop across when we hit that 24 mark. So this is 2 pi over 24, so that is pi over 12. C is the kind of annoying one to find. With C, you're looking for this very special point on the graph where it's in the center and it's coming back up. So you're after that point. In our case, that's 10. It's that special point there. C is 10. Okay, so our graph is going to look like this. H is the a value. So, well, I might actually just write out y is a sine of b, x takes c plus d. We can put in all of our values. So it's 0.5 sine of pi over 12 x take 10 plus 2. And we've got to convert that into h and t. So it's 0.5 sine pi over 12 t take 4 plus 2. Now, there are lots of different ways you can graph it. Why did I go take 4? Take 10. Apologies about that. You could also graph it with like a different c value. You could have it be plus 14 instead of take 10, and that would also work. or you could use like cos. But that's one possible answer there. My recommendation is graph it and make sure it actually looks like that. So that would just be in the graphing mode on your calculator. We might as well have a look. 0.5 sine of fraction pi over 12 x take 10. Just be aware there are technically infinitely many different answers that are all right. So there's no one right answer, although the one that I've got here is probably the most likely one for you to get. And we'll go from 0 up to 3. And then our graph should pretty much look like it's got that shape. And yes, it does. Groovy. If climate change causes sea level to rise, what part of your equation would change? Now, we've got to be really careful. The visible height above the waterline. So it's the total amount that's left. So if the tide goes up, you're able to see less of this thing. So D would lower by 1 because we can see less of it. So the new equation would be H 0.5 sine pi over 12 t take 10 plus 1 instead, because you would see 1 meter less of this structure. Okay, conjecture time. So what we're going to do is pop our calculator back in degrees. So shift set up all the way down here, hit F1 for degrees. All right, sine of 10 is 0.174. Cos of 10 is 0.985. And tan of 10 is 0.176. All right, wonderful stuff. So use table 1 to develop a conjecture. So generally you're looking for how are sine and cos related to tan. So you could try adding them together. So if we try maybe 0.174 plus 0.985. No, it doesn't give you 0.176. That's no good. You try times again, 0.174 times 0.985. No, doesn't really work. Try dividing them, 0.174 divided by 0.985. And ooh, it actually does look like that works. Cool. So we could try the next one, 0.707 divided by 0.707. Hey, cool, you do get 1. That's good. 0.866 divided by 0.5. Hey, you get 1.732. That's good. 0.894 divided by 0.447. And look at that, you get 2. So it looks like tan of theta is sine of theta over cos of theta. And it's also on your formula sheet, so hopefully that looks familiar as well. Okay, consider this right angle triangle. Explain why. So, so this one here is sine theta is opposite over hypotenuse, so that's why that one's true. This one here is cos theta is adjacent over hypotenuse, that's why that one's true. And this one here is tan theta is opposite over adjacent. Okay, so that's why that's true. This is SOHCAHTOA. Now, use your answer from C to prove your conjecture from B. So we'll start, when you're proving a conjecture, it's nicer if you start with the messier thing and try and simplify it to the cleaner thing. So we'll start with sine theta over cos theta. And that's going to equal, well, from here, that's A over C divided by B over C. So that's A over C on the top, and I'm going to do a big divided sign for B over C. When you're dealing with fractions like that, you can flip them. A over C times C over B. So you change the divide to a times and you flip the last fraction. And that's A over B because the C's cancel. And we saw before that A over B was tan theta. Done. Because it was there, A over B. All right. Similar thing here. We just got to set our calculator to radians. So we'll go into shift setup, go down to radians. Okay, 0.4. So cos of 0.4 is 0.921. And cos of 2 pi, take 0.4, is 0.921. Interesting. Okay, now I actually really want to make sure, when I give you a table like this, I do want to make sure that you can actually replicate how I've done the work in this table. So if I do like cos of 0.7, 0.76, or round it up, 0.765. So that's actually partially why I'll fill in some of the table. So if you weren't sure what I meant by filling the gaps, you could try and do, like, for this question, sine of 60 would give you 0.866 on the calculator. Use the data that's already there to make sure you're doing the question right. And for example, cos of 5 pi over 6, if we chuck this into a calculator, you get minus root 3 over 2, which is... Okay, so our conjecture is literally just that they're equal. Cos of theta equals cos of 2 pi take theta. Great, so use your calculator to find a value of theta such that cos of theta is 0.4. So theta is literally just inverse cos of 0.4. There it is, 1.159. So theta roughly equals 1.16 will go. Little c up the top for radians. Watch out for that. Usually you don't need units for radians if you've got like a pi in the angle. Because there's no pi in this angle, it's unclear whether it's degrees or radians, so you need to put little c for radians. There are two values. So this is where our conjecture comes in handy, because the other angle is 2 pi take theta. This is why I got you to do the conjecture. So this is 2 pi take 1.16 roughly, which roughly equals 2 pi take the answer 5.12. There it is, there's the other angle. Illustrate both your answers. So let's convert them to degrees to get an idea of what this looks like. So 1.16 times pi over 180 will convert as the wrong way. It should be times 180 over pi to convert back to degrees. So that's about 66 degrees. And really importantly, the cos value is 0.4. So let's have a look. 0.4 would be about there. And we can see the angle that I'm making to hit that x value is about 1.16 radians. So that's the first thing. And then we've got another angle there. I might use a different color. So down here also has a cos value of 0.4. It's got that same x. And then this angle here is 5.12 radians. Cool. And then they both sort of have that same x value there. So that's what I want, just a picture of both those points. Okay, last question. We got this one. Find cos theta. So sine squared theta plus cos squared theta equals 1 according to that hint. And it's also on your formula sheet there. Just cos first on the formula sheet, which doesn't really matter. So sine is minus 4/5, so minus 4/5 squared plus cos squared theta is 1. So 4/5 squared is 16 over 25, and the minus sign goes away. So that's cos squared theta is 1 take 16 25ths, which is 9 25ths. So cos of theta is root of 9 25ths. Root of 9 is 3, root of 25 is 5. Now you might be wondering what I've done wrong, because it says find both values of cos. You need a plus or minus whenever you solve an equation and take a square root in that process. So plus or minus 3 over 5. Now it's given us an angle range. That, if you convert it back to degrees, is 180 there and 270 there. So whether or not it's positive or negative for cos. So the answer is it is negative because we're down in the bottom left. So sine was minus 4/5, so that's it there. So we could have the point over here or the point over here, but since the angle is between 180 and 270, it would be that point there. And this one here, minus 3/5 is the cos value. So cos theta is minus 3/5. I don't know what the angle itself is, but I do know that it's in that range. So we're in the bottom left quadrant. Cool. All right, find tan. So tan theta, hey, this was that conjecture we had before, is sine theta over cos theta. Sine is minus 4/5, and cos is minus 3/5. You can put this into a calculator if you want, but basically minus 4/5 divided by minus 3/5, you can flip it, times 5 over minus 3. The negatives will cancel off, and so will the 5s, so you got 4/3. That is tan theta. And that's done.